In this video, we look at a couple of examples to discuss the different concept of the AC power. Let's look at this. There's a load. The current through that equals to 4 cosine 100 pi plus 10 degree. The voltage equals 120 cosine 100 pi minus 20 degree volt here. And we'll assume that passive sign convention is followed. Now let's look at the phasor. This is a handwriting big capitalized I as 4, 10 degree, that's phasor, and V 120 magnitude, the angle is minus 20 degree. Now the phasor of RMS values, we take the magnitude divided by square root 2. So I RMS equals 4 divided by square root 2, and that equals to I RMS 10 degree, the same. This quantity is equals to this quantity. And this is a scalar, and this is a complex. You can see handwriting here. I try to bold this symbol, and this is capitalized but not bolded. The same thing for VRMS. We take the magnitude of the sinusoid divided by square root 2. Now, what's the apparent power? Apparent power is IRMS multiplied by VRMS. The values 4 divided by square root 2 and multiplied by 120 divided by square root 2. That equals to 240 VA. Remember, the unit for the apparent power is VA, voltage amp. Power factor cosine theta V minus theta I. We know theta V and we know theta I. We plug it in, we obtain the power factor. We can see theta I is leading theta V. Therefore, this is leading circuit. The current leads voltage. In this case, so if it is a leading current leads the voltage, we should have capacitive load. The impedance should contain negative imaginary part. Okay, we'll see that. Now we use Ohm's law because we know the phasors V and phasors I, we can obtain the impedance. This impedance is just take the ratio of the magnitude and take the difference of the angle. That's equals 30 minus 30 degree. And then we use Euler's formula to obtain the rectangular form that equals 26 minus J15 ohm. We know the impedance equals to R plus JX. R is the resistance and X is the reactance. So we can know that X, in this case, if we compare these two expressions, this is the imaginary part and this is the imaginary part, so they have to equal. Therefore, X has to be equals to minus J15. If the impedance is minus J15, it has to be a capacitor because the impedance of capacitor is 1 over J omega C. Let's figure out the value of the capacitor. So if we solve this equation here, and omega equals 2 from the time domain sinusoid, omega equals to 100 pi. The value of the capacitor equals to 1 divided by 15 multiplied by omega. So that equals to 212.2 microfarad. And we know the resistor is R equals to 26. That's the resistor value, that's 26. So we figure out the impedance, we figure out the capacitor value for this question. Now let's look at another example. Given this circuit, this is a phasor, this is RMS value, this is RM phasor, which means this quantity is RMS value. The phase is 0 degree, that's voltage source here. And what is the average power for this circuit? We can obtain Z, the equivalent impedance. Z equals to 6 in series of 4 ohm in parallel of minus J2. So that's 6 plus 4 multiplied minus J2 and 4 minus J2. And we do a little calculation that equals to 6.8 minus 1.6J. And the polar form is 7. The angle is minus 13.2 degree. The unit is ohm. There are a couple of ways to obtain the average power from here. One is to obtain the power factor, and the average power equals to apparent power multiplied by the power factor, because this quantity, this is apparent power. The power factor is equals to cosine theta w minus theta I. This angle, theta w minus theta I, is exactly the angle of the impedance. From here, we can obtain the power factor, that's cosine, that's exactly this angle, minus 13.2 degree. Next, we need to figure out IRMS. We can use phasor in Ohm's law that equals VRMS. These are in phasor domain here, phasor. And we know the impedance, so we know the phasor of RMS value. This is a value that should be 4.3. The average power equals 30. That's given in the question. And IRMS value 4.3 and multiplied by the power factor. This equals to 125. This is watt. The unit is watt. Or we can use P, we can use the average power equals Rm squared multiplied by R. R is the real part of the impedance. We already obtained the impedance, 6.8, and we have the same thing here.